Okay, please confirm if my screen is visible. Are you able to see my screen? Okay, then. So today we are going to see an interesting topic which is called what? The typecasting in Java. Casting in typecasting. So you get a lot of questions from Java typecasting. So what do you mean by typecasting? Okay, let me put the answer in a layman's term. It is a process, or else I can say that it is a mechanism. It is a mechanism of converting. It is a mechanism of converting what? It is a mechanism of converting a variable from one data type to another data type. Another data type. So when I ask you what is typecasting, you should say it is a mechanism of converting a variable. So you have a variable from one data type to another data type. For example, let us say that if I give you an instruction like this, integer a equal to 100. Here, what is the variable I'm talking about? A is the variable. Okay, A is already declared with the integer data type, int data type. Okay, but if you want to convert this from one data type, which is integer, to another data type, for example, double b equal to a. Now, what is the difference that you see here? We are talking about a variable a. Variable a is declared with the integer data type. So again, what you're trying to do, this variable a is again getting assigned. Okay, it is getting assigned to another variable b. So indirectly, the variable a, which is of integer type, is getting converted to the another variable which is of double type. Which is just an insight. This is just the takeaway. Typecasting is a mechanism of converting a variable. So here we are seeing a variable a. Variable a is declared with integer data type. Okay, converting a variable from one data type to another data type. So integer variable a, which is already with integer data type, is getting converted to double data type. This mechanism is called as what? Typecasting. Okay, so again, the typecasting is divided into, there are two types of typecasting. Two types of typecasting in Java. The first one is you have something like explicit typecasting. Typecasting, and the second one is what? Implicit typecasting. Implicit typecasting. You must understand one thing. I am saying there are two types of typecasting in Java. One is explicit, and second one is what? Implicit typecasting. Right? So this explicit, okay, this developer has to do this explicit typecasting. Developer has to do this typecasting. Okay, the implicit typecasting will be done by the compiler. We will understand in these things in detail. It will be done automatically. Automatically compile. Okay, so first we will discuss about what? We will discuss about what is implicit typecasting, how it can be done by the compiler. We will understand this. What is implicit typecasting? How it will be done by the compiler. Very simple, very simple. Okay, this is also called as what? Implicit typecasting. It will be done by the compiler. It will be done by the Java compiler automatically. Compiler automatically. When you assign a variable from lower data type to higher data type, it is called as what? It is called as implicit typecasting. As the name suggests, what does it really mean is, so you know how many data types are there in Java? There are two types of data types. When I say data types in Java, you have primitive data types. Primitive data types you have And you also have what? You also have the user defined data types. User defined data types. User defined or class data types. Okay, and again under the primitive data types, there are how many data types under the primitive category? You have what? You have byte, you have short, you have integer, you have long, you have float, you have what? Float, and you have what? Double, right? And you also have what? You also have character, and you also have boolean. Okay, these are the available data types under the primitive data category. But if I ask you, how you can if I ask you what is the promotion chart for this primitive data type, what is the promotion chart? Let me give you the promotion chart also. Promotion chart. Promotion chart. So this byte can be promoted to short. Short can be promoted to integer. Integer can be promoted to what? Promoted to long. This long can be promoted to the float data type, and the float data type can be promoted to the double data type, right? And character, the position of the character would come directly under the integer type. This character can be promoted to what? Promoted to the integer data type. If you ask me, sir, what about the boolean? You ask me what about the boolean type, boolean data type. We have something like boolean data type. Will that be participated in the promotion chart? If you ask me like that, I would say no. Boolean will stay all alone. It will not participate in the promotion chart. Now you should ask me, what is this promotion chart that you're talking about? Ask me what? What is this promotion chart that I am talking about? Minute. And it is really slow. What is this promotion chart? Well, let us understand about this promotion chart in detail. Okay, let me open my paint screen. Now we focus here, guys. So you have byte and you have integer, you have char data type, you have long, so many data types are here. So these are called as the primitive data types. Right. Perfect. Increase the size. Focus here. So byte is going to, the size of the byte is how many bytes? 1 byte, isn't it? And the size of the short is how many bytes? 2 bytes, right? And the size of the integer is 3 bytes. And you have long is what? 4 bytes. I'm sorry, 8 bytes, right? The system is working very slow, guys. I'm not. 1, 2, 4 bytes, and you have 8 bytes for long, and you have 4 when float is going to occupy again 4 bytes, double is going to occupy again 8 bytes, right? You have character which is going to occupy 2 bytes. And when I ask you what is the promotion here, what is a promotion here? Okay, now if you look at this chart, you can promote. You can ensure that each and every data type is going to get promoted, right? Now if I ask you, see, okay, the data types can be promoted from left to right. From left to right. In this direction, you can promote the data types from left to right direction. right? And again, there is another direction, there is another promotion direction. So remember this direction, it can be promoted from directly from left to right direction, left to right direction. And again, there is another direction, you can promote from character to double type. So this is another direction. Okay? This is another direction. This is another direction. There is one direction that you cannot do the promotion. Okay, you cannot do the promotion from through this direction. This direction promotion is not possible. Okay, this is not possible, right? When I say let us see some examples here, you will understand it better. If I am taking a data type like I want to say byte a equal to 10, so the value 10 is getting assigned to the variable a, which is of byte type, right? Now what I want to do, I want to take another variable of short type, this b. Okay, so instead of using a value, I want to use the existing value of byte type. Okay, the existing value of byte type. Okay, this value 10, I want to use it again, but I do not want to take the value. Instead, I want to take the variable. I want to take the variable a here. Right, so what I'm doing, okay, after this I want to just print the value b in the console, value b in the console. If I try to do this internally, what will happen behind the scenes? Okay, something will happen behind the scenes, right? And let me compile this, java c space a dot, let me save this first. It has been saved successfully. Java c space a dot java. Okay, then java space here. A lot of time. Okay, let me use the online compiler. Integer a equal to, sorry, byte a equal to 10 I am taking. Byte a equal to 10. Short b equal to a. So I want to do system dot out dot println, and I want to display the value in the console. I want to display, I want to access a variable b. So if I run this code, definitely we would say that the answer is going to be 10. 10 will be displayed on the console. But behind the scenes, what is happening behind the scenes? Okay, you are trying to assign the value 10, which is of byte type, isn't it? If you go back and see the promotion chart, you have a value 10. This value 10 has been assigned to what? It has been assigned on top of byte data type. This value 10 has been assigned on top of byte data type. And you're trying to do the typecasting. You're trying to do the typecasting. Okay. So this value is getting converted from byte to short data type. And if you look at the direction flow, okay, it is in line with the flow that I have that is being shown here. Right? The direction is what? It is getting transferred from byte to short data type. It is in line with the direction. It is aligned with the direction, I can say. Right? This is completely possible. Okay, compare what compiler will do. No matter what, behind the scenes, what is happening? Okay, you are doing this. Okay, let me put it here. For this byte, there will be a memory occupied, right? For one byte, there will be 8 bits of memory behind the scenes. We know these things already, right? So 8 bits of memory will be occupied. 1 and 2, 3, 4, 5, 6, 7, 8. Okay, the value 10 is going to get converted to a binary equivalent binary number, right? So equivalent binary number for the value 10 is what? 1010, right? You have 1 here. You have 0 here, again you have 1 here, you have 0 here. The remaining spaces will be what? Remaining spaces will be filled with zeros. 0, 0. Do you have 0? And here also you have 0. Okay, and so this is going to have the variable name like k. So a equal to 10, this is how it gets represented internally behind the scene. Inside the memory, this is how it is going to get represented. So what I am trying to do here, I am trying to assign this value a, okay, to another variable of what? B, another variable of b. The value a is getting assigned to b. This b is of what type? This b is of short data type. This b is of short data type. So internally what will happen? Okay, this the same registry, okay, what will happen? A memory will be allocated for the short data type. The short data type, the capacity is what? 16 bytes, right? 16 bytes, 2 bytes and 16 bits. So there will be a registry created for 16 bits. Okay, and remaining value will be what? Remaining value will be filled up with the zeros. Okay, everything will be 0. So when you just convert the number that you have in the short data type to the equivalent decimal number, you will get 10 only. But when you look at the memory consumption, okay, this short data type is occupying more memory than the byte data type. But we are not worried about the consumption here. We are actually doing what? We are actually doing the casting here. We are actually doing the type casting here to assign the data type of one variable to the another variable. If you see here, okay, now the memory has been widened, isn't it? Now the memory was limited to 8 bits. Now if you see here, because of this typecasting, memory has been expanded to 16 bits. How is it really possible? Because of what? Because of the typecasting concept. Because of the typecasting concept. You are widening the memory. You are just what? Widening the memory. The same when 10 value, when it is getting occupied in the byte memory, it is consuming this much space. But when you do the same thing, and when you do the same thing by using the typecasting, the same 10 value is going to occupy this much space. It requires 16 bits registry. But in the previous case, it requires only 8 bits registry. But the value is same. So you are doing a conversion. So this conversion is doing what behind the scenes? Memory is getting increased or memory is getting widened, right? Widened. That is why this is also called as what? This concept is also called as what? The widening. Okay. The implicit typecasting is also called as what? Widening. Implicit typecasting is also called as widening. So this will be taken care by the compiler automatically. Right, now we have understood what is typecasting. What are the use cases? What we are going to achieve by doing this kind of typecastings? Okay, now I will give you the small examples. Try to answer to that problem. Just tell me whether it is possible or not possible. Just tell me that. I have a data type like short a equal to 10. Okay, and I want to do what? I want to do integer b equal to a. I want to print the value of. Let's talk about the possibility. Is it possible or not? Just tell me. Is it? Let me take the value as 100. Can you answer me? Just put in the chat box, possible or not possible. Short a equal to 10. I am saying again the second line says the value 10 is getting assigned to the variable b of integer type. I want to print the value b. Is it possible or not possible? I'm asking about the possibility. Come on, answer. Possible, right? Why it is possible? They are very simple here. See, you have 10, you have 100. Okay, 100 is assigned on top of which data type? 100 is assigned on top of short data type. 100 is here. Okay, and you are trying to do the typecasting. 100 is here. 100 is assigned on short data type. Okay. Is it matching? Is it aligned with this direction? See, short is getting converted to integer data type. Look at the direction. Direction is matching, no? Possible. You are converting the value from lower data type. Short is a lower than integer, so you are converting from short to integer data type. Possibility wise, it is completely possible. Why you are taking much time for this? Now let me try to answer this. The next question. Okay, I am taking a byte data type here. Right, I am taking a double here. Now tell me, is it possible or not possible?
Possible.
Possible. Why possible? Because so just to see first value is 100. You are having 100. Okay, you have 100. 100 was placed on the byte data type. You are converting it to the double data type. Where is double? Double is over here. If you look at if you check, it is getting aligned with the direction. Yes, it is. It is moving in this direction. So you are doing what? You are doing the typecasting. Typecasting of what? Implicit typecasting. Okay, converting from lower data type to much higher data type. Completely possible. Right? Now answer this question. Okay, let me run this. You're getting. So output is something like what? 100.0. Why you are getting 100.0? I will give you the explanation. For now, talk about the possibilities. Huh? Now tell me, I have short. Okay, I have what? I have byte. Now tell me, possible or not possible? Think and tell me.
Not possible.
This is not possible. When you why it is not possible? Sir, you have declared 100 to the variable a of short type. But what you are doing, you are doing a mistake here, because again the short is getting converted to byte type. It is not getting aligned with the direction. What do you really mean? You have the value 100 is on short type. Okay, and if you see the alignment, okay, this is on short type. You are trying to decrease it. You are trying to decrease it, which means you are converting from higher data type to lower data type. So we are talking about lower to higher data type conversion. It is reversing. It is getting reversed. It's not getting aligned with this direction. It is from short to byte. Bigger data type to smaller data type. Definitely it is not possible. Definitely it is what is not possible. That's why you get what? You will get compile time error. Possibly logic conversion error you will get. Uncountable type. Possibly logic conversion from short to byte. But trying to convert it from short to byte, which is not possible. It's not what? It is not the concept of implicit typecasting. Right? Now you tell me possible or not possible. I have byte here. I am going to have the character data type. Now tell me possible or not possible. Think and tell me.
Not possible.
Why not possible? Any idea?
Character letters only, sir. Alphabetical.
Okay. Let me introduce this. Character A equal to A. Okay, and I want to do what? I want to do integer B equal to A. Tell me possible or not possible. Talk about the possibility. So when I say possibility, just check these directions. You have a character here. So trying to convert it to integer type here. Don't worry what values are assigned. Okay, look at the direction. I have also declared another direction which is also possible, which means this should be possible, no? Yes or no?
Sir, but integer means we have to give numbers only, sir. But why we are giving alphabetic numbers?
This one, okay, I will tell you. Okay, I have discussed this in the character section. Let me run this. I will tell you. I will answer your question. The output you are getting 65. What is happening behind the scenes now? This character is going to hold a character, but this character is of what? Internally, this character will get converted to an ASCII value. ASCII value is what? 65. 65 ASCII values. Because this value A, the letter A, is mapped to a particular ASCII value called 65 internally. So there is a concept called Unicode concept. Okay. So when you do tell me.
Every alphabetic has a unique number, sir.
Yes, every alphabet has a unique number. No matter what, see, character is a very special data type. You can assign a character firstly. Secondly, you can also assign a number also. For example, let me say if I am assigning 18. If you ask me, sir, is it really possible? Because character is meant to store only the letter. If you ask me such questions, I would say character can accommodate a letter or a number, okay, a number or a Unicode. So we have discussed about this in the character data type, a Unicode, something like 0085. Okay, this is capable to, this character data type is capable to store a letter. If not, it can also store a number. If not, it can also store what? It can also store a Unicode, right? So
when we give higher number, what will change? In character, if we give higher number, what will happen, sir?
nothing will happen. If you see, let me print the character variable a here. You will get the equivalent ASCII value. So the number as an equivalent Unicode, not don't I should not say ASCII value. This number as an equivalent Unicode. Okay, this will get converted to Unicode. That Unicode has mapped to a particular character with this word. So you just do what? Repeat. See my previous video on character data type. 1 hour video is you will get complete understanding about this. Right. So there are so many things internally. See my previous video, you will understand. Okay. Now you see, we are just trying to talk about the possibility. That's it. Okay. I'm asking you whether this is possible or not possible. If I run this code, I should not get error. Right? No, not this. Let me print B. If I run this code, I should not get any error. Why we are not getting any error? Let's check the possibility of this code. Let's check the possibility here. Okay, now you see you have this piece of code. Okay, and look at this promotion chart. From the promotion chart, we can say it very clearly. We can see it very clearly. Right? You have assigned the character A, letter A on top of character data type. Top of what data type? Character data type. Okay, and again, what you are doing? You are doing the implicit typecasting. This A is on character data type. So you are doing the you are typecasting it to what? Integer. Okay, according to this action, it is converting from a character to integer. So this direction is completely valid. I am saying it's getting promoted from character to integer. So there is no violation with the direction. It is as per the promotion chart. Right? That's why it is valid. Possibility wise, it is valid. Why we are doing this, that we will understand. I ask you the same question. If I do double here, now tell me, is it valid or invalid? According to this direction, character A is getting converted to double. Valid. This direction is valid now. Promotion chart, here, this is one of the valid directions and this is another valid direction. Right? So you are converting the value which is of char type to double type. How the conversion will happen? Char will go to integer. Integer will go to, again from integer to long, from long to float, from float to double. It is aligned with the direction. According to the direction, it is valid. Now you tell me, if I ask you whether is it valid or invalid. Instead of double, I am taking long. Valid or invalid? Character is converted to long. Should not think much because valid. Character is getting converted to long. This is a chart, promotion chart. Now if I ask you like whether it is valid or invalid, now you tell me. I have a byte something like I have a number 100. Okay, I am converting this byte to character B. Now you tell me valid or invalid. Okay, let me run this code. What I will be getting? Okay, we are getting something like incompatible types, possibly lossy conversion from byte to char. Why we are getting this? Let me take this piece of code and put it here. Why this is getting invalid? Okay, you have an 100 on byte. I have already told you, no, this direction is not possible. I have marked as a cross here. If you see, this direction is not possible. Byte can be converted to short, but byte cannot be converted to character. Byte can be converted to short or integer or long or float or double. This direction is completely possible. But it cannot redirect. It cannot have this direction, which is what byte can be converted to short, but byte cannot be converted to character. This direction is not possible. That's why I marked it as question. Making sense, everyone? Likewise, so this direction is also not possible. From char to reverse direction is also not possible. Okay, and reverse direction is also not. Reverse direction is possible, but that will come under the explicit typecasting. Okay, this is also not possible. Okay, and you have something like this is not possible. these are the directions that are not even possible. You will get compile time error. Possible? This is not possible. This. If I ask you particularly, if I ask you in the typecasting, since we are discussing about the implicit typecasting, the possible directions are only 3. Implicit typecasting. Implicit typecasting. What are the possible directions? This is one of the possible direction. And you have from character to double direction. And you have from what? From that's it. Only 2 possible directions are there. This one, this one. Let me put the directions here. Okay. Byte to short to long. I mean to int to long to float to double, or else starting from character to int to, again I can copy the same thing, or else that's it. Okay, one direction and the second direction. These 2 directions are what? The possible directions. Making sense? Right? Now one more question. Okay, now answer this question to me. Let me say that I have a value of 1 assigned to the byte data type. I want to typecast it to what? I want to typecast it to the Boolean data type. Let us say that Boolean B equal to A. Okay, I want to print the value of B. Is it possible or not possible? Think and tell me. Okay, and definitely it is not possible. Why not possible? Boolean is not participating in the promotion chart. You see the promotion chart? Do you see the Boolean data type here? It's not that. It will stay all alone. It will not participate in the promotion chart because the Boolean value can represent only 2, can store only 2 kinds of values. One is true or false. Can store either true or false. This true or false literally cannot be converted to these data types. That's why it will never participate in the promotion chart. Making clear? If you get this question in the interview room, we should say it is not possible. Yes or no? Okay, sir, everything is fine. Why did you say that it is what it is? Somewhere I have mentioned that it is implicit typecasting. Why it is implicit typecasting? Why cannot you use some other word? What does it mean to be an implicit? When I say implicit in Java, whenever I am using implicit, what does it really mean? Implicit means compiler will take care, or Java compiler will take care. Java compiler will take care. When I mention the word like implicit, it means Java compiler is going to take care about this. What does it really mean? Now let us go back here and see. Okay, now focus here. Before going to this, now let me ask you one more question. I hope you will answer this. Double A equal to 200, integer B equal to A. Tell me the possibility. Is it possible or not possible?
Not possible, sir.
Not possible. Why not possible? You have a value 200, isn't it?
Sir.
Just blindly imagine this promotion chart. Okay, Sir is trying to do what? Sir is trying to assign a value 200 to the double data type and is converting it to what? It is converting it to the integer data type. There is a violation in the direction. Okay, it is coming in reverse, right? It's coming in the reverse direction. You cannot assign a value which is of higher data type to the lower data type. So definitely will get what? You will get an error. Isn't it? You will get compulsory will get an error. Sir, can you show me the error? Ask me. So this is the error. Possibly lossy conversion. I cannot convert the double to integer. Not possible. Right? So now let us see what is happening behind the scenes. When I say byte A equal to 100, okay, when I say integer B equal to A, okay, system dot out dot println, okay, and you get what? You get something like the value will be 100 only. No, this is very straightforward. Now what is happening behind the scenes? Focus here. Everyone focus here. Okay, this is what? This is the source code. What is the source code? The code that is written, that is developed by the developers. Source code is called as what? Developers. So the name of the file is main itself. So main.java, it has to be stored as main.java, right? Now compiler will come into the picture. Now focus here. There is a concept of compilation. Compiler will check each and everything. What compiler will do? It's going to check each and every line. Moment you give this code to the compiler, how you will give this code to the compiler? You would say java c space main.java. This is the command. As soon as you give this command, the compiler gets activated. We know these things. After the activation, compiler will check each and every line. Each and every line is going to check for the syntax errors or the semantic errors. Okay, it will identify, okay, there is a typecasting happening here. There is a typecasting happening here. We are trying to assign a value which is of lower data type to the higher data type. We are trying to assign a value which is of lower data type to higher data type. What compiler will do? Compiler will ensure that the typecasting is happening implicitly. What does it mean? It will add a typecast operator. Focus here. It will add a typecast operator. Okay, and it will do this implicit conversion. So you don't see this. You don't see what is happening behind the scenes, but compiler will do this. Compiler will add the integer. Okay, it is like, go back to the code. We are not doing anything here, but compiler will ensure that it is getting typecasted implicitly. So it is going to add integer to this value. This a is of byte type. Compiler will do what? Okay, let me take that byte and convert it to the integer. Is doing the conversion. This is called as what? Typecasting, implicit typecasting. Okay, it is ensuring that this variable a is getting compatible with the variable b, which is of integer type. So since you have integer here also it will do the conversion. This will happen implicitly. You don't see these things, but compiler will do this on your behalf. Even though if you do this, no issues. Even though if you do this, you will still get the same output, 100. If you do this or if you don't do this, okay, compiler will doing it. To do this, compiler is much happy about it. But compiler will ensure that, okay, this is byte type, a is of byte type, but our developer is assigning this to what? Integer type. Let me do the implicit typecasting. So it will do integer. This is what implicit, it is adding these things implicitly. Let me take another example. Now if you see something like this, we say byte equal to byte a equal to 10. Okay, what is the proof that it is doing implicitly? I will explain it for you. I am taking a double b equal to a. Now you tell me this is valid or invalid. Possibility, just tell me possible or not possible. Possible, right? Possible. If I print the output in the console, now see the output, you are getting 10.0. You are getting 10.0. Why not 10 you are getting? Why you are not getting 10? Because implicitly conversion is happening. Correct. This value 10 is of what? A byte type. But what compiler will do, it will start checking for all the syntax errors. So it will come to this line, it will come to this next line. Okay, it has identified a typecasting here. What kind of typecasting here? You are converting, you are assigning the lower data type to the higher data type. Okay, so it will do what? It will do this casting implicitly. It will assign the data type of AA. Because of this implicit casting, you are getting the value in the form of what? Fractional part also. The form of what? Fractional part. Making sense, everyone? Implicit casting. Let me take another example. Okay, now what can I take? Okay, let me take character. So Balaji has asked me one question. No? You are assigning a character type here. Okay, now what I am doing? Now tell me the possibility. Is it possible or not possible?
Possible.
Okay, possible. And if you see the output, okay, Balaji is very surprised. Everyone are surprised to see the output as 65.0. What is happening behind the scenes? Okay, this A is getting typecasted to double. A is getting, because of this typecasting operation, you are able to see the changes in the console in such a way that it is getting compatible with the typecasted data type, not character. It is what? It is double. Okay, because of this, what is value is of the what? It is a character, right? This character will be converted to a unique code internally. That unique code have a specific number like 65. 65 is an integer number. That integer number is getting converted to the double number, which is going to leave a fractional part as 65.0. If this typecasting is not happening, you get error. Since compiler is taking care of this, implicitly you're not getting error, and output is getting compatible. You're able to see the compatible output of the respective data type. What if I print A here? You will get directly A as an output. What if I print B here? You are getting value of what? Equivalent data type. Making sense? Implicitly happening. That is what is called as what? Implicit data type. Implicit conversion. Sir, can you show me few more examples on here? So this part is making more sense. Can you show me few more examples? Before going to that, let me ask you a question. Float A equal to 100.0. Okay. Now tell me, possible or not possible? Let's see who is going to tell the right answer. Is it possible or not possible? Everyone, type in the chat box. Just typing, I think. Come on, answer everyone. Possible or not possible? Or don't know? Hello, I'm audible. Guys, tell me, is it possible or not possible? I was on mute. Hello, I'm audible?
Possible, sir.
Possible, no? What about others?
Error, sir.
It will come error. Why error? Possibility is fine, because when you are using the float data type, okay, it is not, we are not breaking the rules of typecasting. We are breaking the rules of data type itself. The value has to be suffixed with f. Think until next time. Okay, now it is possible. Now it is possible. Making sense, right? Okay. Sir, can you show me some real-time examples where this typecasting is happening internally? Sir, okay, let me take integer a equal to 100. Let me take double b equal to 200. 0.00. Say system dot output dot println. Okay, I want to perform the arithmetic operation of a plus b. Okay, a piece of int type and b is of what? B is of the double type. So now tell me what would be the output in the console? Anyone?
300.00.
Why we are getting 300.00? Any idea? Let me tell you that.
Smaller data type to bigger data type.
Correct. But here also internally typecasting is happening. I will tell you what is it. Internally typecasting is happening. We are not able to see that because these are the things that is being taken care by the compiler. Okay, this is the question, right? What is happening behind the scenes? You are saying a plus b. Okay, you have a plus you have b. What compiler will do? So this guy is using a arithmetic addition plus operator, and he has taken two operands. Okay, one operand is of what type? Integer type, and the second operand is of what type? Double type. So both are really not compatible. So to perform this addition, both has to be compatible. The type has to be compatible. Here you have b as what? B is of double type. A is of what? A is of integer type. Okay, compiler will come into the picture. It will say, okay, which is greater, integer or double? Which one is greater? So double is greater. Right? It will typecast the integer data type to double data type. Okay, then both becomes compactable. So b is of double type, a is also of double type. After the compactability, it is performing what? It is performing the addition. So you get what? 300.0. Internally, implicit typecasting is happening, converting one data type to the lower data type to the higher data type. so that the arithmetic operation, the addition operation gets successful. Making sense? Internally, these things are happening. Yes, no, everyone? Let me take another example. Now, now let's see. Now look at this example. We get something. Okay, I am saying I have a equal to 10. I have what? Let me take double b equal to 10.5. Now focus here. So I am using an if condition. Okay, don't worry. What is if? If is just like you pass a value here. It will perform. It will do the conditional check. That's it. Conditional check. After doing the conditional check, it returns. I mean, if it is found to be true, okay, this if block gets executed. If it is found to be false, then the else block gets executed. Actually, you have seen ternary operators, right? Like just like that, right? If you can keep any statement here. Let me take it as I want to do a is double equal to b. Okay, I want to do what? System dot out dot println. I want to print a statement like a and b are equal. Okay, and the next line is else block. I want to use the same system dot out dot println statement. A and b are not equal. Okay, so what would be the output here? Anyone?
Not equal.
They are not equal ideally. So biologically we can say that they are not equal. So how this is getting evaluated? First of all, must understand that who is making this to get evaluated successfully without getting any compile time errors. Okay, if you get this kind of questions in the interview room, our mind will think in a different way. How our mind will think? Okay, a variable a is of integer type. Variable b is of what? Double type. Both are not compatible. When both are not compatible, how it can get compared? How it can? That is how our thoughts will go. But what is happening behind the scenes is, so this, look at this if statement. The if statement is evaluating a if a double equal to b or not. If a is equal to b or not. Okay, but a is of what type? Let me take it here. A double equal to. So a is of what type? A is of integer type. Okay, b is of what type? B is of what type? B is of double type. Okay, so both are not compatible. First, compiler will ensure that these both data types are getting compatible. So this integer will be converted. The lower data type will be converted to the higher data type, which is double. In this case, you have integer and double. So double is higher data type. So that will be placed for the integer. The conversion will happen implicitly. Now both are compatible. Okay, after the compatibility, how the values will be represented? Now 10.0 will be checked for the equality with 10.5. Okay, this is going to return what? This is going to return false. They are not equal, of course. This is going to return false. When false is returned, this if blocks will not get executed. This will be skipped. Okay, the else block gets executed. A and B are not equal. So you have to understand something here. Even though they are not compatible, internally something is happening which you and me are not able to see. Those things are taken care by the compiler. Compiler is doing all these things. Compiler is ensuring that the integer is getting converted to double data type. So this is called as what? Implicit typecasting. These things are happening implicitly. The things that you don't see. The things which you don't see. This is one of the example. Okay, now in the interview, if anyone is asking, see guys, this typecasting, there are so many times you get this typecasting question interview. Okay? Do not get any panic. Very, very easy to understand. Just remember this. What is typecasting? Typecasting is a mechanism of a variable, converting a variable from one data type to another. Typecasting is done. Follow-up question. How many types of typecasting? You have explicit typecasting, which is to be discussed tomorrow or day after tomorrow, and you have implicit typecasting. So what is implicit typecasting? It is a typecasting which will be done by the compiler automatically. What is the promotion chart? Okay, they will give you this kind of questions by sharing their screen, you should answer them. Is it possible or not possible? You should remember the promotion chart, byte, short, integer, promotion chart which I have shown. This is the promotion chart. Right? Will Boolean participate in the typecasting? No, it will never participate in the typecasting. Boolean will never participate in typecasting. Why? Because every in the remaining data type, okay, in this data types, you can everything is a number. So byte is a number, short is a number, integer is a number, long is a number, float is a number, double is a number, character is a letter. But internally, that letter is mapped to a particular number again. These are all of a numerical type. These all data stuff completely numeric in nature. That's why you can deal with this. When conversion is happening between these data types. But Boolean is something that is storing true or false. That's why it is not participating in the typecasting concept. It would stay all around. Now, why it is called as widening? I have given you the example why it is widening. Okay, it is widening because this is a widening. Okay, byte is this and this is the short. Right? This byte, this is short. Right? The memory size is increasing because of typecasting. Internally, the memory allocation is getting increased. Right? And what else we have? Why it is implicit? Implicit is typecasting is also called as widening. This will be taken care by the compiler automatically. If you are very clever enough, if you do not want to want the compiler to take care of this, you can also do this. You can also explicitly specify that, no issues. But that will not make any sense. Right? Implicit means Java compiler will take care. Any questions for me on top of this typecasting? Do you have any questions on this? Everyone? Yes, no? Will you able to answer what is typecasting?
No, sir.
What about others? Only Sudhir is responding. Any questions, everyone? Type in the chat box at least.
Yes, sir.
Okay. So tomorrow we will see about the explicit typecasting, because to understand explicit typecasting, we have to understand few more concepts. Okay. After understanding this, we will develop a small tiny application so that you will understand. And one more thing, guys. Even in the interview room nowadays, what they are expecting is focus. Who are trying for a job, focus here. Okay, they are expecting two things nowadays. Nowadays the market is like, okay, you can be a front-end developer, or you can be a back-end developer, or you can be both. You can be both. So let us say that this is front-end developer. Okay. Let us say this is a back-end developer. As per the analytics, as per the research, Java, if you have 10 openings, 6 openings will be for Java. 2 openings will be for Python. For the backend, I am talking about. And the remaining openings will be for what? These databases, and you have the something like the remaining programming languages. You have PHP, Ruby, so many programming languages are there. Out of the 6 openings are there. So sometimes they will ask about, are you a full stack developer? You can say yes, because full stack developer is like, let me take about front end. Front end JavaScript is doing good. Okay, and you have what? React.js. React.js is something doing very well in the market. React.js. You can learn. If you have time, you can learn. You can learn this too. You can learn only Python. You can learn. I'm not asking you to learn everything. If you want to become a complete backend engineer, okay, so since we are good with Java, we will be going with Java, right? And if I ask you, are you okay to be a full stack developer? Full stack developer is like, you should be very good in backend. Very good. You should be very good in backend. Again, should have at least some basics about front end. Some basics. Or else, opposite. You should be very good in front end. Okay? And you can have some basics in back end. So this is the third option. Since we are backend developers, we are learning Java, we will be backend developers. We will be backend developers. If you want to become the full stack developer also, that is possible. After starting our career in the backend developer, we can focus on the front end. You can focus on the front end. You can learn simple things, not much in detail. Okay, as per the market, 60% openings are there in the Java programming, for the Java programming language, because I have some of my friends who are keeping the resume. they're getting a lot of calls for the Java. So they are keeping resume for 4+ years and all. So Python, the calls for Python is like 1 or 2 in a week. That too, if you keep experience like 6 to 7 years. I don't think that Java is outdated. Java is king in the market. It's doing king in the market now. Try to focus the basics. Whatever I'm teaching, these are the complete basics. These are the complete fundamentals. You don't just just listen to the classes. Also, you do some practice at least 1 hour a day. So these things may be looking very simple, but if you're not able to answer these simple things in the interview room, okay, it will be very ridiculous. Right? Update yourself every day. Just if you read this, that is enough for a day. Right? So that's all from my side. If you have any questions, you can ask me. I will be here for 5 minutes.